Hello again, dear students. Today we are going to finish these examples that we have in 7.2, which was about solving len. What do you mean by len? Means that if I have fractions, we say that if you have a fractions, the first of all, we are going to think about len. Why? Because you see, if I have u du here, or up or here, directly I have len of u plus c. Thank you. Then it will be better. Thank you. Yeah, good. So that's why we are thinking about that. But do not forget about the previous ideas. Like what? Like if I have something like that, we know this one also is fraction. We cannot solve it, right? Why I cannot solve it? Because the derivative of denominator is what? It's like a today's quiz actually. Is what? The derivative of denominator. So let me give you two examples. This is the first example, this is the second example. I have what? I have 1 minus x squared dx. Can you imagine what's the difference between them? How we solve the first, how we solve the second. That's the idea, means that if you can solve this one, if you can distinguish between these type, means that you understand. Why? Because I know the first one, the second one is easy. Derivative of here is equal to what? Minus 2. Am I right? Now everything is ready, and I can say is equal to 1 minus x squared plus c, but also I have what? Minus 1 over 2. Understood? Why? Because the derivative of here, but the derivative of here is equal to what? It's not equal to 2x. Am I right? Is equal to what? Is equal to 1 over 2, 1 minus x squared multiply 2x. This is the derivative of denominator. Am I right? Did this one exist in the numerator? No, we have just 2x. So I cannot solve by len. I told you, solve everything. No, think about everything. When you have a reciprocal, when you have a fraction, think about len first. But I don't say it's everything. Because here we have another idea that we mentioned before, that you saw today. And later in Cal 2, you have another method. So that's why you should put everything in its place in your mind. So how we solve the second one, the first one? The first one I say is equal to what? Is equal to 1 minus x squared minus 1 over 2. Am I right? X dx. Now I'm going to solve that one as a u du. I'm going to rename that part as a u. So derivative of here is equal to minus 1 over 2. So I can see is equal to what? Is equal to 1 minus x squared, 1 over 2 plus 1 over 2 plus c. We add 1 and we divide by the new 1. Understood? So two methods, even we have a fraction, you should be careful. For the first one, we use the u du, but we should bring it to up. And for the second one, it's len directly. You don't need to do anything. So len is easier than the previous one. Okay, now you have an idea. You should collect this idea. You should write your note. You are just listening and look at it. It's not working with you, actually. You should write your note. Otherwise, you'll mix everything. I remember we solved tan, we solved cotan. I left cotan for you, I think. And we solved tan, so I'm going to solve second. Second is one of the irregular, or like, let me say, it's one of the most common integral, which you can't solve by your mind. You need the method. So I'm going to give you the method. The same thing is true for second, okay? For cosecond, sorry. For second, let me ask you a question. Integral of second is equal to what? Do we have any direct things is equal to? No. We have many things. Maybe in your mind, we have that one. Yes, you are right. This one is equal to tan of x plus c. Maybe in your mind, we have that. That's why I say collect everything and put it in the right place, because otherwise you cannot control it. Integral of that one is equal to what? Second. You should write these notes every day to deal with it. But for the second, we cannot say anything. We haven't. There is no direct. So how we solve? That's the question. So what's the relation between this subject, 7.2, natural logarithm, and integral of the natural logarithm, like that? What's the relation between that one and that one? Ln of u plus c. What's the relation between them? Why we mentioned here? That's the question. Understood, dear? Hello? Good. So how we solve this one? How we solve it? Second should be multiplied by something. Do not ask me why, because each step I'm going to answer you later. What do you mean by that? So I have second of x. I'm going to multiply by this part. Second of x plus tan of x, second of x plus tan of x dx. Can I do it or not as a mathematics logic? Yes, right? A over a is equal to 1. So a plus b over a plus b is equal to 1. Am I right? Understood? Good. But why we multiply by that one? That's the question that I say don't ask, because later I'm going to answer it. So now we are multiplying this numerator here to here and there. And I'll get what, dears? Yalla. Second square at the beginning, okay, plus second tan, let me write like that for you is better. Second tan, okay, over. Am I right? Understood? Why we multiplied? Tell me. Now, yeah, exactly. But why we do like that? Why that one? Why that one? Look at here. Derivative of second is equal to what? S, huh? Second tan. And derivative of tan is equal to what? Second square. Right? So now you answer me. Derivative of I have a fraction. Derivative of denominator exists in numerator. So which method we should solve this one? How we should solve that one, huh? UDU. So UDU. What do you mean by that? Can I write like that? Or not? Am I right? Derivative of denominator exists in numerator. So we say ln of denominator. Easy or not? Now easy, but before it's hard. Why? So now you understand why we multiply here. And now you understand why we bring this one to here. Understood? This box is very important. We are bringing it from our pocket because we have no idea about that one. It's proved like that actually. Then we multiply the numerator. Later we will get the derivative of denominator. Understood, dear? So tell me about cosecant. Look, that means you understand. The cosecant of x. Yalla. How we solve that one? Okay. Yes. Multiply by what? Okay. Cosecant plus cotan over the same. So cosecant cotan of x. Okay, later, next step, multiply. Now you are dealing with it. So I will get cosecant square, cosecant cotan x over cosecant cotan dx. Later, we add لن how? يلا day. So we have a fraction. I'm going to check the derivative of denominator. Do not mix the steps. That's it. So derivative of cosecant. Cosecant cotan, but something missed. Yes, minus. Am I right? How about derivative of cotan? Minus cosecant square. Am I right? So we need to multiply by minus here. Understood? So now we have what? We have minus ln of cosecant cotan. It wasn't easy, but it wasn't big deal because you saw this one before. Now you are ready. So anywhere when you saw integral of second, you should bring in your mind this package. Understood? Because later in Cal 2, we are going to solve second cube. Here in Cal 1, we solve second. We solve second square. We solve second tan, right? So there, we are going to solve second cube. And you will see this one. So you should control these subjects. Then here we can deal with that one. So do it. If you are a student of the science or the engineering, you need these informations. So please, for integral, deal with it. It's not hard. Actually, it was interesting things. It's not like the previous one. Domain and range is equal. No, it's not like that. Just need work. Just recognize it and put it. Now it's Cal 2. Now this is about how we solve cosecant, how we solve cosecant. And this is the summarize of your duty that we did. Now you have tan 2x dx from 6 to pi over 6. So how we solve that one? Even you have tan is equal to that one. You have information about that because tan cannot be solved directly. We change it to sine over cosine. Then we bring the ln and we multiply. Do you remember that? And we go that one and we go that one, that one. So tell me about 2x. Here's a 2x. What's going on? The same method. I say is equal to, forget about the boundary. Later I'm going to put it. I say is equal to sine 2x cosine 2x dx. Derivative of denominator is equal to what? Minus minus sine. What else? Derivative of denominator. Minus 2, you are right. So we need minus 2 outside. Now here derivative is u, here's du, and here's the fraction. So how we solve that one? Ln of understood? Okay, instead of c we have what? We have boundary. So I'm going to put the boundary here, and we know how we solve this. So is equal to what? Minus 1 over 2 ln of cosine 2 pi over 6 minus ln of cosine 2 multiply 0, and you will get the result. I don't know. Use the table that I gave you before in the beginning, chapter 1. Then you will find the result. So my question, why this one changed to pi over 3? Yeah, because I told you there's two methods to solve that one, or you are going to change the angle, or you can use that method. I recommend you to follow that one as well. It is easier for you. Understood? That's about how to solve that one. Now we have an example. Find dy by dx if y is equal to 1. I'm going to summarize this section for you. 7.2. We have natural logarithm, means that the ln. The important things here with the ln, we say that the first graph, the second domain of this ln and range of this ln. The third, it was properties. The fourth, it was derivative. If y is equal to ln of x, so what's a derivative? The fifth one, yes, integral of du, which is equal to ln of u plus c. The last one, benefit or usage or how to use application. Understood? So quickly reviewing for you. We say the graph is like that. Sorry. We say the graph is like that. 2 and 3 together is like that. Also, I remember I gave you something else also here. Property and limit. Do you remember? Okay. We say the graph is like that. Y is equal to ln of x. The domain, it was from 0 to infinite and minus infinite. X-axis, y-axis. And also we say the limit, the important things here, limit x approach to positive 0 to ln of x is equal to minus infinite. And also I gave you x approach to infinite for ln of x is equal to infinite. Do you remember that? And also we say if y is equal to ln of u, y prime will be 1 over u prime. Do you remember that? And we say that if I have any u du, directly I can write ln of u plus c. Now the last one, application. What's the application? For example, if I say find the derivative of such thing like that, y is equal to, okay, x squared plus 1, x squared plus 1, okay, x plus 3, and x minus 1. I say find y prime. So what's the relation between y prime and this fraction? Why we mentioned this example here? Why? Just guess. Yalla, just guess. Why? For example, during the final exam, I say find the derivative of that one. You can find it how? In the chapter 3 and 4. How is so? Yes. So we say the denominator square, right? Denominator multiply, but we get what? Long things. Maybe you need 10 minutes or 15 minutes. But if you are solving this one by ln, it will help you. How? You can use ln for solving that one. And later you will see in the indeterminate form, Barana Diarakan, in where in the 5.7, there we are going to use this idea. That's why you mentioned here. So I say y, I say ln of y, look at here, is equal to ln of x squared plus 1, x plus 3, 1 over 2, over Understood? Understood? Okay. So now I'm going to use the property of ln. I'm going to write like that. So tell me if you don't know how. You know why? You see, if you have a fraction, AB is ln A minus ln B. Am I right? Okay. How about multiplication is going to be what? Again, did you understand what did I do? We have multiplication, so I'm going to make it 2 ln with addition. Do you remember that? The first property. Also, I'm going to write this part am I right? Power can be here and bring it to here. The fourth property. Do you remember that? If you don't remember, just look at it. Now I have ln of y equal to that one. So what was the question? Find what? Derivative, right? Find what? Find derivative, y prime. So now y prime is equal to what? I say is equal to 1y y prime. Am I right? Why? Because it's an implicit function. Because it's implicit function. In Kurdish. Now the derivative of here is equal to what? To x. Easy. How about the second derivative? Right? How about the third derivative? So say derivative is equal to that one, all these over or multiply by y, not over. So it's equal to what? Equal to 2x x squared plus 1 over 2x plus 3 minus 1 over x minus 1 multiply by y. Understood? And y, you know, is equal to what? Write y, substitute. So it means that for exam, this one is easier. Time consuming. Understood? Help you to not waste your time for getting mark. And we are going to use this method later in the 7.5, as I mentioned for you in what? In indeterminate form here. We need this informations. Understood, dears? Especially for type C. We have some types like that. So next week, we are going to control these two subjects together, 7.3 and 7.5, and it will be interesting. Any question about natural logarithm? Dears? No question? Good. So thank you for listening.